In this video, I'd like to do some preliminary data analysis using the data set that we just looked at on movies. And the questions I have in mind have to do with profitability. I'd like to just see something about how profitability may or may not have changed over time, and whether that varies for different kinds of movies. Let's say genre, does profit vary by genre? And is there some interaction between how profits vary by type of movie and over time? Has that been changing? So those are kind of questions I have in mind to analyze. So let's start with the just looking at profitability itself. My profitability measure, remember, is not true profitability, but it's the closest we can get from this kind of data, which is saying for each dollar spent on making the movie, how much does it earn? Bigger than one means potentially a profit. Less than one means pretty certainly not a profit, a loss. So let's see what that looks like. You could do this under analyzed distribution. The other way to do it, you can do it using the graph builder. So let me go to the graph builder. If all you want to do is look at that one variable, you can drop that one variable profitability into either X or Y. Drop it into X. Well, all the points are kind of crowded here on the left, and what I see are really three outliers. Up here, you'll notice there are different graph types. You can change the graph type. If you change it to what's called a box plot, I guess it actually doesn't show up here. Let me go back to the points. We'll look at that later. Well, I see some outliers here, but in fact, I see 3 points that are way outside everything else. Let's take one of these tools up here, the lasso, and let's lasso those 3 points. I've highlighted 3. Notice on the bottom left of the screen, selected 3. Select them in a graph, they're selected in the data set. What are those 3 movies that have such huge measures of profitability? I mean, more than 12,000. That means for each dollar spent, it earned more than $12,000. That's huge profits. So the 3 have been highlighted, 85,000 rows. I don't think I want to scroll through and try to see what those 3 are. The quickest way to get them is to go under tables, subset. It will subset right now all the columns, but for the rows that were selected. So you click OK, and here are those 3 movies. One main reason to look at outliers is they often are errors in some way or not relevant to your analysis. So this is one way to check. In this case, though, take a look at the top 2 here. The Blair Witch Project, that movie, 1999, that was a famous movie because it was shot with a handheld camera. It was very low budget. It cost, I believe, $60,000, yes, in its original dollars. Updated to today's dollars for inflation, that budget is 97, a little more than $97,000, but it earned worldwide $404 million. That's really, really high profits. So the profitability measure is 4,144 essentially. Second movie down here, Paranormal Activity. That's another one very similar. It was extremely cheap to make, much more recent, 2007. In today's dollars, its cost was only $19,000, a little less than $20,000, and yet it earned $253 million worldwide. By far the most profitable movie by this measure. That's legitimate. Those are outliers, should not be excluded. If I found something that looked like an error, I might exclude it from the analysis, but there's no basis for excluding it. In fact, those are correct. Those two movies are well known as being extremely low budget, highly successful movies. This Korean film I had never heard of, though, so I know nothing about it. 2007, it claims to have never earned any money in the US, but it did earn money worldwide. It had $1,000 budget in 2007. Well, I see no reason to exclude it. It could be a mistake. You know, it's hard to make a movie for $1,000. I have no idea how they did that or what the story is. If it really mattered, this would be a case where you'd want to do more research. Maybe you could find something about that movie by doing a search, and maybe by looking at that, you'd find that the $1,000 figure is right. It was a made-up number, or maybe you'd find out it is right. Generally, I would advise against excluding data unless you have a very good reason. A not good reason to exclude data would be it doesn't look right to you. It doesn't look like what you expected. Yeah, it's not a legitimate reason for excluding data. If you go down that road, before you know it, anything that doesn't conform to what you thought would be true, you start excluding, and then you end up concluding, just like I thought. Well, of course, because you excluded everything contrary. The reason for looking at data is to discover whether your initial conceptions were right, or is there a different story that is more consistent with the evidence. So don't erase evidence because it's not consistent. Erase evidence because it's wrong. If you can document that it's a mistake, or it's just not believable. Those $1 budgets to me are not believable. It's quite possible that you can make a movie for $1 if it's done under some special government policy where they said, you know, we will pay the bills, but you just have to record $1. Then it may be the right number, but it's not useful for analyzing profitability of movies because it's not really what the market will allow you to make movies for. So sometimes you have to exclude data, but be careful about that. Don't just exclude things because they don't look like what you expected. So I see those are legitimate profitability. So I'm going to leave them in the data set. So let's do a different graph. My first question is, has profitability changed over time? Let's put profitability into Y. And let's take year and drop that into X. It's a little bigger. So you notice because the profitability is so high on those three movies, they sort of stand out, and the scale of the graph, you can't tell what's going on with the other. I mean, we have profitability for almost 10,000 movies here. What do those 10,000 points look like? We could exclude those, but then they'd be excluded from analysis. The best thing here, we could hide them so that they don't show up in the picture. Maybe I should try that. Let's see how that works. Let me circle those, and under rows, just click the hide, not exclude. So if I do analysis, they'd be included, but you've noticed they've been hidden from this picture. And let's try starting over, because I think it will now rescale for us. Put profitability here. Unfortunately, no, it kept the scale the same. So even then, I'm going to have to change the scale manually. So if you put your cursor over the y-axis and double click, it brings up a dialog for changing the scaling. The numbers can't go below 0, but it looks like most of the movies are well under 100 for the profitability measure. And most of the real big budget movies certainly cost quite a bit to make. I mean, if you spend $200 million on a movie, there's no way you're going to earn more than 10 times that in revenue. So 100 for the profitability measure as a maximum seems quite reasonable. Let's click OK. And now I want to go back to just the select arrow. Now, this is what our data looks like. Now, if you look at it, what you notice is it's not actually showing the data points. If we actually click on the data points, here are all the data points. And there are so many movies in these later years that they're just stacked up on top of each other. That's why the default graph automatically deferred to what's known as a box plot. The box plots make it a bit easier to look at. And what a box plot is it puts a box around the middle 50% of the data. And let me pick one that's a little easier to look at. If you look at this year 1984 right here, you can see there's a little segment below the box. That's the first 25% of the data. So 25% of the movies made in that year had profitability measures somewhere in that fairly narrow range below the box. Then the box contains the middle 50% of the data with the median, where 50% of the movies are above and 50% are below, being the line across the middle. So it's broken into 25% increments, 25% below the box, the next 25% for the first half of the box, the next 25% for the next half of the box, then 25% of this movies in the top segment. And if things are far enough away from the rest, they just appear as points, separate points. They're outliers. The box plot is known as the box and whisker plot because if you look at it sort of sideways, you can see in the middle there's a box and then there's whiskers out to each side. A little easier to see if you do it this way. Analyze distribution of profitability. Let's try it. Let's look at it sideways. On the red arrow, remember, anytime you see a red arrow, you can click on it, get new options. That changes its orientation. Let's change the scale here to go from 0 to 100 in increments of 10. Well, it's even hard to see. Here's a box on the left. That's 50% of the data is inside that box. The left-hand part of it is too small to show up even. So that's why you can't see it. There's a tail to the right of the box, which is this whole line segment, and you have a whole lot of outliers. And if you look at the histogram, it's a little easier to see. It's got sort of a big bar at very low value of profitability, and then a skewed distribution showing relatively small number of movies with higher measures of profitability. Almost any kind of monetary variable is going to be highly skewed, whether it's people's incomes or credit card balances or movie profitability. It's a very unequal world, and that's what shows up as a skewed distribution where you have a relatively small number of very high values, but most of the values are in a very sort of narrow range. It's kind of hard to see if there's any kind of general tendency in this picture. Movies become more profitable over time or not. So maybe if we simplify the picture a little, there's a smoother, which will basically create a smooth relationship between the two. And you can adjust how smooth it is or isn't by taking this lambda and moving it one way or the other. The more you move it to the left, the more it starts mimicking the detail that's in the data. the more you move it to the right, the smoother it gets. If you go all the way to the right, it becomes pretty much almost a straight line. If anything, it looks to me like profitability has actually tended downward a little bit in terms of the average profitability. So the smoothed relationship looks pretty flat, but actually I see it tapering off a little. You could also fit a straight line through it. You can't this way. The reason that this picture didn't look like I expected is because it thinks that the year is a nominal variable. So in fact, let's try it this way. If you go back in the data set and you were to change year to a continuous variable, and now you take year and put it on the x-axis and profitability on the y-axis. Change the scale again, 0 to 100. Now, if you fit a line, you do get a best fitting straight line through the data points. And the shaded area is a confidence interval, more advanced topic, but basically recognizing that there's a lot of variability in profitability of movies. So it's basically showing 95% confidence that the average relationship between profitability and year looks like this straight line. You'll notice it's much wider in the early years because there are very few movies there, so you can't be very confident. But when you have a large number of movies made, which is pretty much 1980 to 2020, it's a narrower range. But it doesn't look like profitability has generally been, if anything, it looks like it's been slightly decreasing over time. Why could that be? That could be because the budgets have been getting bigger. It's harder to make money if you spend a lot of money on the movie. Well, let's take a look at that. Let's go to start over. And let's try putting time here on the x-axis. And let's look at the budgets in US dollars adjusted for inflation. So the adjusted real budget. You put the points back, oh, there are all the points in a smooth relationship, or let's say a straight line through that. The straight line can show you a number of things here. It's basically right now fitting a linear relationship between them. It looks almost horizontal. Like on average, the budget of the movie has not changed, but you notice all these points up here, lots of outliers at high values. I actually think this picture will look better if we go back here and change year to a nominal variable. And notice you don't have to redo the diagram. I changed it to a nominal variable. It has already changed up here. And I think the way we'd want to look at this would be to look at the box plot again. This one you can see a little clearer, and actually you can actually see the boxes here. If you look at this year, like 1992 here, see the left hand or the bottom part. I'm thinking left because I'm turning my head sideways, but the bottom part is 25% of the movies are in that range. Then the next 25% and the next 25%, and these 25%, it looks like there's one outlier that year. So I do sort of see waves here in terms of budget, where the budget sort of looks like they were increasing in this time frame, and then they started decreasing again. but lots of outliers. So we have lots of expensive movies that have been getting made. Well, we want to compare the budget to the revenues. Let's see what the revenues look like over time. If you drop that on the y-axis below the other, you get a separate picture for that. Another option would be to click start over. Let me put year back on this x-axis. Right now, all that's shown is the number of movies in each of the years. And whether this was COVID, it probably was COVID that there's this reduction in 2020. It could also be that data is incomplete whenever it was collected. But 2019, it was already dropping a bit. But up until that point, it had been a steady increase in the number of movies over time. But as soon as you want to put something else in the picture, it will replace the number with whatever you're putting in. If you click on the revenues and the budget at the same time, highlight both and drop them, instead of getting two separate pictures, they will be put into one picture, which may or may not be easier to look at. And I don't think it is easier to look at. What you're actually getting is two separate box plots for each year, one for the budget and one in one color and one for the revenue, for the world revenues in the other color. Which if you click undo, take it back one step. If you put them in separately, here's the adjusted real budget. World revenues drop underneath. That picture in this case is somewhat easier to look at, although neither paints you a very clear picture. If you wanted to put this into an analysis that you're writing up, one important step is to click on the red arrow and uncheck show control panel. The show control panel has all of this extra stuff around the sides. It helps you build the graph, but it's not useful information. So if you uncheck it, it's a cleaner picture. I would also advise changing titles and things, so you can highlight this, put in a more meaningful title. I don't know that you need a legend out here because the legend appears on the left side as well with the labels. So you could, at the red arrow, it says show legend, uncheck that, the legend disappears. And when you get something you want, you can then go either under edit to copy, or inside here, right click, go to edit, copy graph, and paste it into a word processor, and you'll have a much better looking graph than if you just take the entire window. Don't take screenshots. Copy and paste works much better, because if you take a screenshot, you're going to get all kinds of extraneous stuff that you don't need. Of course, if you want to modify the graph, you got to put the control panel back so you can look at it. One of the powers of Graph Builder is that most analysis is meaningful if you do multivariate analysis. So you don't want to just look at two variables. You want to look at more than two, and it's not that easy to visualize more than two. So for instance, one thing you could do here is you could take, well, does this vary, this trend, if you're looking at movies that are made in the US versus somewhere else? We could drop that into the group box, and now you have separate graphs for USA and for other countries. Allows you to compare. It does look like some of the budget numbers are higher in the USA, so these outliers say higher up. The pattern doesn't look to me that different, although it's not a real clear pattern anyway, but I see somewhat higher numbers here in the, like, I think 1990 to 2005 timeframe. somewhat lower numbers after that. That's on the budget. Revenue is much harder to look at here. Start over, let's just put back the profitability measure. By year, and change the scale. And actually, let's make the scale even a little more narrow. Let's say 0 to 50 in increments of 5. So a lot more outliers as you get to later times. You notice the boxes in the middle have gotten somewhat smaller because there's a lot more movies. All of this prior to 1970 something, the financial data on the movies is just fairly scarce. So one option here might be to say, you know, we're not going to get much analysis out of the before 1970 time frame. So maybe one thing we should do, actually close that window, is let's select where the year is less than 1980, let's say. That's 21,000 of these movies. Let's go hide and exclude. Let's see if we draw a different picture now. Now our data in the picture is starting at 1980. Let's put profitability here. Again, we need to change the scale because there's still a few movies that have such high profitability, it's throwing the picture off. You can see the boxes for each year now, and you can see the outliers. I don't see a clear trend in profitability there. If we take A and maybe we want to drop that over here. US or UK is the bottom graph. Other countries is the top graph. You can try to explore whether there's a difference. I'm not seeing a strong difference there. If you undo that, you can just see there's different places you could drop this. You could drop this. If you have more than 2 categories and you drop it into the wrap box, you'll get smaller pictures for any number of categories. But I only have 2 categories here, so dropping it in the X, but group X or group Y is about the only place you could do that. If you put the points in, you could take US, UK, and you could drop that in the color box. It will be make it a bit bigger. So you've got blue and red, and if I get the panel, will be easier to see. Still kind of hard to see, but it colored the US and UK movies in one color and all other countries in another color. There's still too many movies, but I think if you would click on the magnifier, you know, we could highlight one particular year here. Shouldn't have clicked that extra time. We're looking at one year here. Change it to that. Oh, so the points are hard to see. If you right click, points, graph marker size, make them large. That's much better. So I picked up part of the next year here, but here, so this is the left-hand side, that was that year, and you can see the US and the other countries' points. Not pictures showing you anything, but basically, I'm just trying to show you some of the tools you can use. So lots of things can be adjusted here. Right-click in JMP is often a very useful thing to do because there's lots of things you can customize with that and change. So don't forget about the right-click button. Don't forget about the red arrows. I'll show you one more part here. If we go back to, let's just go back to start over. And let's take year and profitability again. Change the scale again. So let's say we want to see how the profitability varies by genre. The problem with the genres is we had way too many categories and we couldn't reduce it very easily because it was in alphabetical order. So it's not like you could take the first word and say that's the primary type. It just happens to be alphabetically the first type. So with that many categories, there's no way to put them in the picture. What we would do is click on the red arrow and say local data filter. And we could take genre plus sign. It is now added. Let's get rid of the control panel. So here are the 715 action movies, profitability over time. And maybe instead of box plots, gonna go back, put back the control panel here for a minute. Let's put the points. And maybe instead of the points, let's put bars for the average. You can change from average to something else here. Drop down menu, could make it the median, but let's use the mean, the average. So there's movies just listed as action. An adventure, and that's what they look like. And you can scroll through these. I mean, we've got 1,257 categories, so there's a lot. And some of these categories have very few movies, so it makes sense only to look at the ones that have a fair number, 156 movies, comedy, family, and fantasy. And that's what the average profitability looks like. See a lot of movies here that are crime, drama, and thriller. Average profitability. So data filters can be very good for exploring the data. They're good in presentations where you can do it interactively in front of an audience. They are not very good for printed documents or even electronic sent documents. If you send them a document, if they can't interact with it, you're best off just pulling out a snapshot you thought were useful to look at. But if you have the opportunity to do it interactively, the local data filter interact with it a great deal. To really analyze genre, I'd have to spend some time reducing these categories. So we want to look at it. You could, for instance, create a column that says, take any column that includes action as one of the words. And if it contains action, call it action type. Otherwise, some other. So some movies will contain action as one of the words and some will not. And you could do the same thing for drama and for major categories. So you try to reduce this into just a few major categories, and then you could analyze it. And let's just look at one more thing here. Let's remove the local data filter. And the red arrow, remove local data filter. What about relationship between the ratings that people gave it, viewers, their average vote, which ranges again from 1 to 10, and the score that critics give the movies? there's the smooth relationship. If you add the points in, there's lots of movies here, so there's a lot of points that show up. But it's pretty clear that in general, they are related. As the people rated higher, the critics also rated more highly. So critics and people are not that different. But there's a fair amount of scatter here, and sometimes it's most interesting to look at the things that are way out of the range of the others. So we could, for instance, lasso a few of these points. These are ones that the public liked quite a bit, but not so much the critics. And with them highlighted, you can just go to table subset. Those 6 movies I heard of the butterfly effect, but I'm not positive. So for the most part, I have never heard of any of these. Don't think they got too many votes. Well, one of them is so that the butterfly effect actually got quite a few votes too. Never heard of it though. So those don't tell me much, but maybe the other end will tell us something. Let's lasso these that maybe we'll take those two. So the critics liked these much better than the public did. Again, these are not any I've ever heard of. Nope. Nope, those 4 I've not heard of. I don't know what that is, but so sometimes it's fun to explore those. I mean, I think often the outliers are things that are not among the most interesting to examine. But in this case, didn't reveal much. I guess maybe we could have picked ones up here to move that the critics really liked and only got mediocre votes from the public. But main thing about the graph builder is it should be used interactively. It's very easy to play with, so you want to use it for exploration. Eventually, you will use visualizations to convey to people, to communicate what you found. But by far, the most important use of visualization is to help you understand the data. So your initial exploration of the data, and far more than doing any of the analysis platforms, before you analyze data, is to explore it and explore it visually so that you get a feel for what relationships look like they are important in this data and what are not. And there's lots of options here, so you really need to play with them. There's no universal guide to what visualization should you draw for what kind of data. There are a number of software programs that try to suggest those to you. I've not found those very successful or useful because often you will find something on your own, some way of looking at the data that is more meaningful than what would be the typical advice of how to look at it. But a lot of options are very interactive platforms, so there's a lot you can do with this. And when you want to look at multivariate analysis, more than 2 things, that's where these boxes come in. You can color points, you can change their size, you can overlay things so that more than one variable appears on that y-axis. So there's a number of ways to rearrange the picture so that it's showing more than 2 things. There's a limit to how many different dimensions you can get into a picture, though, and still have it be intelligible. So that's a little introduction to exploratory analysis.